Hey, folks, before we get going, let's look at a situation where we would need to factor. So let's say you had something similar to this right here, like x squared plus 11x equals negative 18. Okay. Usually in the past, when we've had a variable like x and a number or a constant like, negative 18, we would try to isolate the constant on one side and the x's on the other side. And then be able to solve by adding and subtracting and dividing and all that kind of stuff. Well, in this situation with quadratics, this is called a quadratic when you have a squared term right here. You can't do that. You can't just divide everything by 11 or divide everything by x. So you need to use factoring. Excuse me. You need to use factoring if you're going to solve it algebraically. There are graphical ways of solving it, but to solve it algebraically, here's what you would do. You'd move the 18 to the other side by adding. It almost seems like the wrong thing to do, doesn't it? Like we're going to add 18. Then you have the x's, like terms with x's in them on one side, and you would have a 0 on the right side. Well, this is a very powerful thing because if I have two factors, two things that multiply together that give me 0, then one of these two, this one or that one, needs to be equal to 0, right? Like if this was 5, well, 5 times what is 0? It would have to be a 0 here, right? Or if we undid that and said, okay, well, let's say, how would I know that one's 5? Let's say this one over here is 3. Then this one would have to be 0. 0 times 3 would give me 0. So that's called the zero product property. And that's what we're going to ultimately use. And I think, factoring without knowing some of that might seem like a pointless exercise. So factoring is a very important concept. And the good news is it's not that hard, right? Because you guys know how to FOIL or expand or use the distributive property, as we've talked about. Like we got to take x times x, we got to take x times negative 3, right? We got to take 5 times x, we got to take 5 times negative 3. Now, I want to point one thing out real quick here. The 5 times negative 3, that generates negative 15, right? So the last two numbers in our factor have to generate the constant at the end, right? So let's focus for a second on this example. And you see an 18 at the end of the trinomial. So if I had two factors multiplied together, that's what we're trying to do. And by the way, we're trying to factor trinomials, 1, 2, 3 terms with a leading coefficient of 1. So that makes life a lot easier, and I'm going to explain that in just a second. But let's stick with the 15 idea over here, the negative 15, right? If I wanted to get a negative 15, I could have 5 times negative 3, right? Or I could have had a 1 and say a negative 15 over here. So we're not exactly sure if we couldn't see the factors. Like if I want to get 18, I need two numbers that will give me the product to be 18. So let's write a little table down here, and we're going to say the product is 18. And then let's see here. What two numbers could give me 18? Well, 2 times 9 could, or 1 times 18, or 6 times 3 could give me that, right? Could give me the 18. Now, let's get back to the leading coefficient of 1. If we had two binomials multiplied together, the first terms, the x times the x gives us x squared, right? There's no other way to get x squared if we're going to have, polynomials here, than to have an x here and an x over here. So I'm going to put x. I just know this has to be an x and this has to be an x because the only way we're going to get that 1x squared is if it's a 1x times a 1x. All right. So that makes this concept today a little bit easier. We don't have to worry about this leading term, this number over here, this x squared, because it's a 1x squared. So we know we have a 1x times a 1x. Now, let's get back to the 18 business. Okay. So I don't take one of these over here. Let's take 6 and 3. So maybe you want to hold off writing this down in your notes because I'm picking the wrong ones. But for just a second, let's say you just pick 6 and 3. Okay. Yeah, because you're a beginner, you don't know. I'm just trying whatever, I'm just guessing here. So let's say I had 6 and 3 there. Well, look, the 6 times the 3 is definitely giving me the 18 right up there. Otherwise, I wouldn't have put 6 and 3 right here, right? However, we have more to do than just the first and the last. So let me highlight it in yellow. The x times the 3 over here and the 5 times the x, the insides, they have to add up to be the number that goes in the middle, right? The number that's in the middle comes from doing 3 or negative 3x in this case, negative 3x and positive 5x over here. That gives me the middle term, right? So I'm just coming up with these two factors. We know how to multiply these factors together. And this concept over here is based on us knowing how to multiply these two factors together. So what happens here? I need to have, let's go back to yellow here for a second, if it lets me. I need to have these two multiplied together and these two multiplied together. And when we do that, we need to be able to add them, right? Because that's what we do with the middle terms here, because they're like terms, we can add them together. And you might say, well, this is subtraction over here. Yeah, sometimes it's going to be subtraction. So what happens if I had 6 and 3? Well, I get 3x and I get 6x, and that gives me a total of 9x. But no, wait a minute. What did I really want in my problem? I wanted an 11x, right? I want it to be 11x. So what that means is in my table over here, I'm going to put down sum has to be a positive 11. Okay, so you put in the table, you put the middle coefficient, the middle term's coefficient, and that means I got to have 11. Well, when you look right here, now it makes it really obvious this is the one we want, because 2 plus 9 gives me 11, right? 1 and 18, 1 plus 18 gives me 19, and 6 plus 3, as you just saw, gives me 9, right? So I don't want that. So the one I do want is the 2 and the 9. So what I'm going to do is I'm going to grab my eraser, and I'm going to erase the 6, I'm going to erase the 3 and this work down here, and I'm going to put the, let me go back here, I'm going to put the 2 and the 9 in. So I go 2 and 9. Now, does it matter? Like if you put the 9 over here and the 2 over here, it doesn't matter at all. So I get, let's see, when I multiply in here, I get 2x, right? 2x. And when I multiply out here, I get 9x. So this is how we factor a trinomial with a leading coefficient of 1. You put a little table down and you try to figure out what these two factors need to be to give you 18 and what these two need to be to add together to give you the middle term. And the table will help us out a little bit, okay? So here's what we're going to do. We're going to do one more example. You can see that this example is really similar. We got an x squared and x squared, right? It's always going to have 1x squared on our problems today. They won't have a 1 there. Remember, invisible 1. And then this has an 18, same as this problem up here. But look at the middle term. It's negative 9 now. So if I'm doing one like this where there's a negative in the middle, okay, so let's look at our little chart over here. We still want two numbers that will multiply to give us 18, okay? Multiply to give 18. But this time we want them to add together to give negative 9. Now, you might think about this as add or subtract, okay, because you'll see here in a second what I'm talking about. So if I want 18, positive 18, I could get that, like I did up here, positive 2 times positive 9, positive 1 times positive 18, positive 6 times positive 3. Or I could get it as a negative 2 times a negative 9. Or a negative 3 times a negative 6. Or I could have a negative 1 times a negative 18, right? So now I end up with negative 11 or negative 9 or negative 19, okay? So which one do I want? Well, I want this one right here. Let me circle it in yellow again. I want this one right here because it's going to give me the correct middle term of a negative 9x, right? So I put down two sets of parentheses. I had a teacher one time say double bubble. We're going to put down two sets of parentheses. She thought of this as like bubbles. I don't know, whatever. So anyways, all these problems today, you're going to have an x here and an x there because the leading term is 1x squared. And then what your goal is to figure out, what goes in the other two factors, right? So I had that circled in red. And these two terms right here have to multiply to give us 18. and have to add together to give us that -9. Now, you might be saying, Nelson, stop talking, man. I see which ones they are. You made it real clear in the table that I put a -3 and a -6 down because that's going to generate this trinomial right up here if these were the factors. Okay, now here's what's going to happen. If you're in class, we're going to do this problem and this problem with the partner on the whiteboard. If you're not in class, you're at home, then I want you to try these problems, and then you're going to put them into McGraw-Hill to see if you get them right. Okay, thanks for watching my video. I hope you can be here in class. If you're not here in class, just do the best you can, because we are going to talk about some more of these and practice some more together. So it's best that you can, be in class as much as you can. So appreciate you though watching the video. Thanks.